Yeah. Yeah. Morning, everyone. So before I go, can anyone please confirm whether my voice is audible or not?
Yeah, it's loud and clear.
Fine. Hadoop architecture. Storage architectural see, Hadoop is meant for two things: storage and processing. Storage architectural components. Storage architectural components and processing architectural components. Processing architectural components. Okay. So Hadoop is meant for two things. Generally, any technology if you take, it is meant either for storage or processing, but Hadoop is meant for both storage and processing. It is going to store huge data and process that huge data within quick time. Storage and for processing. Storing, okay. So Hadoop doesn't use any database. Databases has got a lot of drawbacks. The drawbacks like limited storage, no parallel processing, volume increases, speed decreases, and mainly databases can handle only structured data, but most of the data today is unstructured format. So Hadoop can handle all varieties of data. So despite of databases, Hadoop is going with a kind of file system called Hadoop Distributed File System, HDFS, Hadoop Distributed File System. And for processing, Hadoop doesn't use any current technology. It is going with a processing model like parallel processing, like map reduce. It is going with the map reduce. Fine. So here we have got three things here. For storage architectural components, processing architectural components. Storage and processing. Okay. We have got name node, uh, data node, name node, data node, and secondary name node.
Charger.
Secondary name node. Please be in mute. Name node, data node, and secondary name node. Three things. And for processing, we have got two components like job tracker, task tracker, job tracker, and task tracker. Okay. So this is what Hadoop is providing two services: storage and processing. And this we call it as storage architectural components. These are processing. This we call it as storage architectural components. Storage architectural components. And this is what processing architectural components. Processing architectural components. Okay. Storage and processing, storage HDFS for processing MapReduce, and for this we have got name node, data node, and secondary name node, and for processing we got a job tracker, task tracker. Fine. Now I'll discuss one by one what is name node, data node, secondary name node, job tracker, what happening internally within this. Okay. Observe. Name node. Name node. See, Hadoop follows master and slave architecture. This is master, multiple slaves. Single master, multiple slaves. Single master and multiple slaves. Okay. S1, S2, so on, Sn. Okay, this is my master. This we call it as master node, name node. Name node. These are data nodes. These slaves we call it as data nodes. See what happening within the name node, what happening within the data nodes. Okay. So name node, generally it is name node. For example, these data nodes are going to store the data, they are going to process the data. See that name node, for example, task 1, task 2, task 3. Task 1 by S1, task 2 by S2, task 3 by S3. Three tasks are executed by the three slaves parallelly. Three tasks are executed by the three slaves parallelly. Suddenly, if any slave goes down, then the task of this will be allocated to any of the other slave. That is fault tolerance mechanism. But if one slave goes down, then we have got another slave. We have got another slave to process that. But if a name node goes down, if name node goes down, then immediately secondary name node comes into picture. Secondary name node comes into picture. Okay. Now, what happening within this name node? What happening within this name node? Think I want a file f1.txt, f1.txt file. Okay. File. The file size, think it is some 192 MB. Generally in Hadoop, the file divided into blocks. The file is divided into blocks. The blocks are distributed across the slabs. So here number of blocks. Can anyone confirm? Did I discuss about secondary name node in the last class?
No, sir.
Number of blocks in Hadoop. The number of blocks equal to file size by default block size. In Hadoop, always the block size is 64 MB. Default means file is divided into blocks. What is the size of each block? 64 MB. So if any file of any size, it is going to be divided into blocks, 64 MB blocks. So now here how many? 64, 64, 64. You will get a three blocks. B1, B2, B3. Observe here B1, B2, and B3. B1 consisting of some 10 lakh records, B2 consisting of some 10 lakh records, B3 consisting of 10 lakh records or transactions. How they are going to get stored here within this mask?
Sir,
This is my
sorry.
mask.
Sir, sorry. Last time you spoke about it, like default size is 64 MB, and then there is a replication on which we are replicating
Okay.
information, different things.
No.
We discuss it.
About secondary name node.
No, no, you have not thought of secondary.
Okay,
Yeah,
one second.
secondary we have not. You have not. Yeah.
No. This one you can observe here. Yeah.
Mhm.
If to understand secondary name node, you need to know what internally happening within this name node. Everyone. Observe. Please be in mute.
Hello,
Everyone,
sir.
please be in mute. Please be in mute, everyone. So just for the interaction and for the sessions to be interactive, I just kept I've unmuted everyone. So if you feel that any background noise from your side, you can just text me. You can use the chat panel for that. Okay, fine. Yeah, any queries? So in Hadoop, data is stored in the form of files. Files subdivided into blocks. The blocks are going. This is data node 1, data node 2, data node 3 slaves. So here B1 stored here, B2 stored here, B3 stored here. This is the name node. This is the name node. So here if you observe, when the data blocks is going to occupy some physical memory location address. These are going to occupy some physical memory location addresses. See XX, YY, ZZ. So what are these? What are these? Yeah, exactly. Hadoop block size is 128 MB from the latest version. Yeah, from Hadoop 2 onwards, we have got as 128 MB. So I said I'll be discussing both architectures. Architecture of before and architecture from Hadoop 2 onwards. From Hadoop 2 onwards, lot of architectural changes we have got. So first, I'll be discussing this so that even if you are going like tomorrow, if they ask what are the architectural changes you see before and after. So here it was 64. Next, I'll say with 128 MB, yarn, yet another resource negotiated. We have got high availability. we see high availability there in yarn, that is from Hadoop 2. Fine. So both I'm going to cover. We can just say the differentiation. So if any query asked, you'll be able to answer it. So just not only 1 2 3 differences I'm going to show you, nearly 10 to 15 differences I'm going to show you. What are the architectural changes you see? What are the differences you observe? Are differences between Hadoop 0 version, 1 version, and Hadoop 2 version? From Hadoop 2 in Hadoop 0 and 1 version, there were some drawbacks. All those were rectified in the Hadoop 2 version. So what are those, and what are the storage point of view? What are the changes? Processing point of view? What are the changes you observe? And what are the in block size? What are the changes you observe? And in other things. Okay. So further to understand it, first you need to know that previously how was the architecture, and now what was the changes you observed. Okay, fine. So here this, see, data is going to be splitted into blocks. The blocks are distributed across the slaves, and this see, this B1 block is going to have some physical memory location address, B2 also, and B3 also. This we call it as physical memory location addresses. Physical memory location addresses. Okay, fine. So here name node always, see, in Hadoop always the data stored within this data nodes. Data nodes. How the data stored means in the form of blocks. One file data is stored across multiple slaves, multiple data nodes. If you want parallel processing to happen. And in the name node, it won't store any data. It will store metadata. What it stores? Metadata information, data about data. Now coming to this name node. Now you see f1.txt file divided into blocks. What is this? Blocks. Into how many blocks? This is blocks. B1 block, B2 block, and B3 block. And where B1 stored? In S1 slave 1, in slave 2, in slave 3. These are blocks, these are slaves, and where, okay, again, blocks information, slaves information, and this physical memory location addresses. XX some address, YY some address, some addresses. So this everything should be maintained by this name node. Blocks information, the slaves, and the physical memory location addresses, everything. Tomorrow, like if you want to combine this f1.txt, so like f1.txt nothing but consisting of how many blocks? B1, B2, B3. So B1 means it should just B1, B2, B3. It should access that memory location addresses XX, YY, and Z. To access this B1, B2, B3, XX, YY, and Z. Physical memory location addresses. Fine. Now, sir. Now, based on this, just try to say, second, notepad. Let me open notepad. Name node responsibilities. File, open. Now try to say name node responsibilities. What are the name node responsibilities? Anyone? What are the name node responsibilities? I want the sessions to be interactive. Name node responsibilities.
It
Based on this.
stores the metadata about data nodes.
So just I showed you. Okay. Still. Yes. So here I'm saying name node, about this name node. It stores blocks, slaves, mainly physical memory location addresses. If you want to come tomorrow, like if you want to read f1.txt, it's stored across multiple slaves. Which block stored in which slave, in which memory location addresses? So if you want to combine it, name node need to perform that. It should have the information about it, the physical memory locations of the blocks of the file. So here, first name node responsibilities to store the physical memory locations, to store the physical memory locations of the blocks of the blocks of a file to store the physical memory locations of the blocks of a file. Next, to combine physical memory locations, to combine the physical memory locations of the blocks, so that the file can be formulated. To store the physical memory locations of the blocks of a file, to combine the physical memory locations of the block so that the file can be formatted or the file can be retrieved. And name node stores the metadata information. Name node stores the metadata information. Okay. Who divides the file into blocks? Who divides the file into blocks? And stores in multiple slaves? Who divides the file into blocks and stores it in okay? Name node, it stores the different blocks in different slaves. And who assigns the tasks to the slaves? See, one second. Anything task related means processing components, job tracker, anything storage. See, this job tracker, task tracker names are also changed. They are in the Hadoop 2 version also. There are some changes you are seeing. You are not going to see this job tracker and task trackers. Instead, you got resource manager, node manager, other thing. Okay. Okay. Storage architectural components, processing architectural components. So anything processing related taken care by processing architectural components. Storage related taken care by this. Okay. Now coming back. So these three responsibilities: name node stores the metadata information. Data node responsibilities. Data node responsibilities means only one responsibility: to store the blocks, to store the data blocks. Who is going to process the task? Who is going to execute the tasks? Who is going to process the data? Processing components to store the blocks. So this is mainly data node is used to store the data blocks. Name node is to store the metadata information and physical memory location addresses and the blocks of a file. Next, secondary name node. Just like if I take an example, in the absence of the principal, vice principal, the same way in that whenever name node down, immediately secondary name node comes. But in that from Hadoop 2, you can see some high availability. You can see secondary name node. Secondary name node. See, when name node is down, then the entire cluster will be down. Entire cluster is down. Entire cluster will be in spectator mode. They cannot perform anything. No storage, no processing. If name node is down, I'll say in the coming session, everything. If name node is down, everything is down. Spectator. So when name node is down, immediately secondary name node comes into picture. Secondary name node comes into picture. Secondary name node responsibilities. Same as a name node. What is it? Secondary name node responsibilities. Secondary name node responsibilities. Same as name node. Same thing. The same thing I copied. Same as name node. But if you observe here, secondary name node is not 100% backup node for name node. What is this? Secondary name node SNN. SNN is not 100%, is not 100% backup node. Secondary name node is not 100% backup node for name node. Name node. See, observe this. What is the difference between name node? Just like in the absence of the principal, vice principal comes, but vice principal will don't have the total authority in performing the operations. Only is just going to act in the absence of the principal. The same way, secondary name node is also, it doesn't have that full privileges. So name node can read, write. Name node can read, write, and update. Name node can read, write, and update, but secondary name node can only read. Secondary name node can only read. Name node can read, write, and update, but secondary name node can only read. But secondary name node can only read, cannot write or update. But cannot write or update. Cannot write or update. Okay, observe this. Observe this diagram once, everyone. If you want to understand internally what happening within this nodes, name nodes, secondary name nodes, observe this. If I take this is a name node, first understand what happening within this name node. This is the name node. This is the name node. Name node I'm saying. Name node consists of Name node consists of every node within a cluster, within a Hadoop cluster, is going to have LFS, local file system, and Hadoop distributed file system. So can let me know how many of you have got 1 second, whether discussing how many of you have got knowledge on Linux. Can you please type in the chat panel yes or no? Everyone just please try to type in the chat panel whether it is yes or no. Not a problem even if it doesn't have knowledge on Linux. Just I'm going to discuss, but everyone please try to confirm.
Sorry, I'm not able to find that dialog box, but I don't have knowledge on Linux.
Dialog box. Your good name?
My name is Sandeep. I'm not able to find chat window. Some problem with my setting. I'm just trying to figure it out.
Okay. Okay. Fine. Chart will be there. Chart. Okay. Fine, not a problem. Okay. So I'll be discussing that commands, basic Linux commands. So for HDFS, to understand HDFS, this is basic commands. Okay. I'll be discussing before, and today I'll be taking your mail IDs. I'll be forwarding the software. In the tomorrow session, I'll be demonstrating about the software, and I'll be discussing the basic Linux commands. Not a problem. Okay. I'll be just discussing everything and I'll be showing you all those before I go with the actual practicals of Hadoop HDFS Linux commands. I'll be showing you, and so generally in every node, Hadoop in a node, name node consists of LFS, HDFS, LFS and HDFS. Okay, fine. Hadoop distributed file system and local file system Linux. So Hadoop distributed file system. Okay, I said in Hadoop how the data is stored. Okay, form of files f1.txt. This file divided into blocks. File is going to be divided into blocks. Where these blocks are stored? Not in the name node. It is no way. It is not stored within that name node. It is stored within the. It is going to be stored within the data nodes. So here, this metadata information. Metadata about this metadata information. Metadata also stored in the form of blocks. Metadata also stored in the form of blocks. Metadata is also stored in the form of blocks, like in this way here. And this is also stored. This is also getting stored within that. There is a temp folder. There is a temp folder available. Okay, also stored in this temp folder. Also stored within this temp folder. From this temp folder, in a timely manner. Copied into two special files. Called as fs image and edits. Fs image into two files. Fs image is a file name. Edits is a file name. Fs image and edits. Fine. So in a timely manner, copied into two special files. What are the file names? Fs image and edits. Timely manner means hourly. It can be daily. It can be weekly. It can be hourly, daily, weekly. Into this two special files. Fs image and edits. Fine. So this is fs image and edits. Fs image and edits. So from this temp folder, copied into this hourly or daily. Fine. So these things you need to understand how this data is stored, how the metadata is stored. Name node stores metadata is in. How that metadata is stored in the form of blocks. What is that default block says 64 MB, but from the latest versions you are getting 128 MB. So metadata also stored in the form of blocks. Later the metadata again stored in the special files called fs image and edits. Okay, understood everyone? Any queries here? Fine. Next.
Sir, about temp folder copying and periodically it is moving into special files. So how secure
Yeah,
it is? Like the metadata, if it is available into temp folder, that could be read by
that's the
if
reason
using a
temporarily it is stored. Temporarily means if you want hourly you can just take it, or daily or weekly. You are just metadata information only, not the data data is stored within this metadata only. Why metadata? Because for example, for processing any file, metadata information is available.
No, I mean,
Here,
if that file, if hacker wants to, just he just encrypt it or just corrupt that, then physical location will not be available through that metadata file.
that's the
So
reason metadata. Okay, it's not only stored within the HDFS, it is also stored in the LFS. In the HDFS, it is stored. In LFS, it's stored. In the metadata, it's stored in the form of blocks here. So in a temp folder, from there timely manner, it is going to be stored in FS image and edits files. Tomorrow, if name node is down, secondary name node is going to come into picture. So from this the secondary name node, if it wants to process, it should require it. If we want to process any file, that it requires metadata. So it should get that metadata from this FS image and edits files. I'll just compare that name node and secondary name node now. And one thing, Hadoop is not for uh, Hadoop is not for OLTP processing, online transactional processing. Hadoop is for batch processing. Lakhs and millions of records. You are just going to pull and you are going to process it. It's not for OLTP. It's not for online processing. Online processing means user interactive. Here, user non-interactive. What is this? Hadoop means batch means what? User non-interactive. OLTP means user interactive. If you are performing one online transaction, OLTP, online transactional batch processing means user
we
interactive.
talked on this. We,
Yeah,
we talked on this in detail last session.
yes, that's what. Now, comparing this name node and secondary name node. Name node and secondary name node. 1 second. This is a name. For example, 7 to 8, morning 7 a.m. to 8 a.m. Name node running 8 a.m. to 9 a.m. Name node running. Think that at 9 a.m. name node down. When name node down from 9 to 10, secondary name node is running. Again, think that at 10 a.m. again name node up and name node is running. 10 to 11 name node running. Means here if you observe, for 1 hour name node was down. In that case, secondary name node was running. So this is my master. This is my master. This is the slave. Sorry. Secondary name node. This is the secondary name node. This is name node. Name node, secondary name node. Name node, secondary name node. Every node is going to have LFS, HDFS. LFS, HDFS. Now, f1.txt file divided into smaller parts like blocks distributed across multiple slaves. So, but that metadata information are stored in the form of blocks. From here in a also stored in temp folder. Temp folder. So here we have got fs image and edits, fs image and edits files. So from morning 7 a.m. to 8 a.m. name node was running. The metadata information copied into this. 8 to 9 also it was running. But at 9 o'clock it was down. At 9 o'clock it was down. So secondary name node comes into picture and fs image and edits whatever data present it is going to take, and after that it is going to perform the processing operations. Next, between 9 to 10 whatever data metadata generated. So everything will be stored within the temp folder. So from 9 to 10, secondary name node is going to run and stores that everything within this temp folder. At 10 o'clock, when name node is up, at 10 o'clock, but secondary name node cannot write or update into FS image or edits. It can only read secondary name node. Secondary name node cannot write or update into FS image or edits. So second name node, when it is up, it is going to read this and going to update that into this FS image and edits. Update. One second. Okay. So when a name node is up, it is going to read from the temp folder and is going to just update into FS. Means it can name node can read, write, or update into FS image and edits during its presence and during its absence. But secondary name node can only read, cannot write or update into that. So here only name node can here name node can read, write, and update into FS image and edits files. Secondary name node can only read but cannot write or update. Okay. No. But if you observe from Hadoop onwards, we have got high availability. From Hadoop onwards, we have got high availability. Multiple name nodes. Name node 1, name node 2, name node 3. Name node 1, name node 2, and name node 3. When name node 1 is active, name node 2 will be in passive mode. Only one name node will be in active, the other will be in passive. From Hadoop 2 version onwards, we can have multiple name nodes. One name node will be active, others will be in passive mode. Active name nodes, okay, this passive name nodes will keep collecting metadata from active name node. Suddenly, if this active name node is down, immediately anyone will become active. This will become active. If this is also down, then this becomes active. This is what high availability we say. This we say it as high availability. Next is like processing or textual components. Processing or textual components. Processing or textual components. First one. Job tracker, JT, task tracker. Job tracker and task tracker. Job tracker and task tracker. Job tracker resides, so this job tracker resides master node. Task tracker resides within the slave node. Maximum possible name nodes, it's not only 3, you can go with multiple name nodes. But generally, we won't go those many of more than 3. Generally, we'll go with some, but suddenly all at a time, name node 1 down, name node 2, name node 3, everything they cannot be. We can go with multiple name nodes. If one name node down, other name node becomes active. If that is also down, we have got 3. We can go with multiple name nodes. With a multiple of 3. Fine. So here, if you observe, this is my master. This is my master node. These are my slaves. These are my slave nodes. Master node. These are the slaves. So within that master node, we have got a name node. Job tracker resides. Job tracker resides within the master node, and this is data node 1, data node 2, data node 3. Data node 1, data node 2, data node 3. Task tracker 1, task tracker 2, task tracker n. So in every data node, how many data nodes? See, I can say like a number of task trackers. Number of task trackers equal to number of data nodes. Number of data nodes. Job tracker going to divides the job into tasks and assigns the task to multiple task trackers. T1 task to task tracker 1, T2 to task tracker 2, T3 to task tracker 3. So these multiple tasks are executed by multiple task trackers simultaneously, executed parallelly, and gives the result. During this process, if any system goes down, and if the task tracker, then the task of this T2 is going to be assigned to any of the other slave or other task tracker. That we call it as fault tolerance mechanism. What is it? Fault tolerance mechanism. Okay. So here, if any storage request comes, that request goes to name node. If any processing request comes, it goes to job tracker. And if any storage request comes, first name node takes that request and divides that file into blocks and stores the blocks across multiple slaves. If any job request, any processing request has come, it divides the job into tasks, and the tasks are distributed across. They are executed by multiple data nodes. Now, understood. Number of tasks. Now, job tracker responsibilities. Job tracker responsibilities. Job tracker responsibilities. First one, task assignment. Task assignment. Load balancing. Task job tracker responsibilities, nothing but a task assigning tasks, load balancing, and fault tolerance. If any slave goes down, then in its place, the task need to be processed by any of the other slave. Fault tolerance. Task assignment, load balancing, and fault tolerance. Okay. Task tracker responsibilities. Task tracker responsibilities. Executing the tasks. Executing the tasks given by job tracker. Sense acknowledgement. Task tracker sense heartbeat signals. Task tracker sends heartbeat signals to job tracker for every 3 seconds. For every 3 seconds. I've got some couple of queries here. How job tracker comes to know that particular task tracker is down? Based on heartbeat signals. If the heartbeat signals are missing, job tracker thinks the task tracker is down. Immediately it is going to reassign. Now I've got some queries. Now try to answer everyone. I want responses from your side. First one. Who is the master for the storage? Now about the entire architecture. Who is the master for the storage? Yes. Answer. Who is the master for the storage? Storage means processing means job tracker. Storage means name node. Yeah, name node. Name node. Who is the master for the processing? Who is the master for the processing? Who is the master for processing? For processing related, everything taken care by job tracker. Who divides the job into tasks? Who divides the job into tasks? Who divides the job into tasks? Yeah, job tracker. I want quick responses from you, everyone. Job tracker. The job tracker, I'm saying. Next. Who assigns the task? Who assigns the tasks? Who assigns the task to task trackers? Task trackers. Yeah, who assigns the tasks? The tasks to task trackers. Job here also it is job tracker. Who handles that fault tolerance? Who handles the fault tolerance? If any slave goes down, the task is going to be assigned to any of the other slave. Who handles the fault tolerance? Who handles the fault tolerance? Job tracker only. If any task, if any slave is failed, the task is going to be reassigned to any of the other. Divides the job into tasks, assign the task to task trackers, handles the fault tolerance. No. Who executes the tasks? Who executes the tasks? Who executes the tasks? Task tracker. Task trackers. Who divides a file into blocks? Who divides a file into blocks? File means into blocks means storage related. Name node. Who is that? Name node. Who stores the actual file blocks? Who stores the actual file blocks? Data node. Who divides a file into blocks? Name node. Who stores the actual file blocks? Data node. Master for storage, master for processing. Who stores the who stores metadata information? Who stores the metadata? Name node. So these things you need to understand. Okay, fine. Fine. Okay. Now, okay, fine. So as you said, most of you doesn't have knowledge on this Linux. I'll be just discussing the Linux basic Linux commands. Based on that, you can understand that HDFS commands. So step by step, command by command, we are going to execute even in HDFS. So I'm going to provide you. I'm just going to provide you software to your Google Drives. You can just download and you can just make your software ready before I go with Hadoop Practicals HDFS. So parallelly, if you want, you can just execute along with me. First, you can practice. Fine. I'll just demonstrate it, what I'm going to forward you. So meanwhile, every one of you can just, 1 second. Everyone type your mail IDs in the chat panel once for sending this software, and the notes also I'll be forwarding in the coming sessions. Gmail, why? Because Google Drive should be a Google Drive. Gmail account I want. Everyone. Okay, I'll forward the software and I'll just demonstrate you what you are able, what you need to do. Fine. Fine. Explorer. If you know the basics of, CoreJava, it's fine. Even if it doesn't have, so anyhow we are going to discuss like Pig Latin is there for Pig, for Hive SQL languages are there. Basics of SQL, basics of Java, if you know, it's fine. So here I'm going to forward you this rar file. Can you see this rar file and this keys, VMware Pro keys, VMware Pro keys. So whenever this will be really of 5 GB size, 5.5 GB it will be. So you can just download. If you doesn't have unlimited net, you can just by other means you can just download it. Extract it first. Extract it. If you extract it, you will get two things. One is a VMware workstation, you will get Xubuntu, you will get two things. If you extract this rar file, you will get VMware workstation and this Xubuntu. Install this VMware workstation software, VMware workstation. At the last, it will ask for a key. So this license key I have provided you. You can use any of that license key which is provided in that. It gets installed. After that, this is the folder which is this you are going to see Xubuntu. After that, you will get a after that you will get this Xubuntu folder once you have extracted it, and on your desktop you will get that shortcut. Okay. First you download and just down. You do one thing. After installing this VMware, I'll just show you how to work in Cloudera environment also. And here, this VMware workstation, you can see that shot on your screen. You will see this. Okay, you just in tomorrow session, I'll demonstrate. First, you download and keep it, and install that VM. This is that. Just download it and install this VMware workstation. Normal installation. Next, and keep that. And what you need to do next, I'm going to say you in the tomorrow's start of the session. And tomorrow, just I'll be go with the basic Linux commands before I go with the actual protocols of HDFS. They all okay, fine. So for today, just I'll stop here. We'll continue tomorrow. First, I'll show you that demonstration of the software, where Linux basic Linux commands. Okay, fine. Any other queries you have got? Anyone? Okay, fine. Okay, I'm stopping here. Tomorrow we'll continue.